Coding was never the hard part. You have probably heard this a lot since AI started writing code. The argument usually goes something like, writing code is easy, the difficult part is figuring out what to build. And honestly, I think that statement is incredibly misleading. Because if coding was really that easy, why did we spend decades building an entire profession around it? Why were great programmers paid so much? Why did companies obsess over finding 10x engineers? Why did programmers burn out trying to ship software? And perhaps most importantly, why is software still so damn buggy? Let's start with the obvious question. If coding is easy, why does an entire industry exist around teaching people how to code? We have computer science degrees, boot camps, programming books that are hundreds of pages long, books like Clean Code and The Pragmatic Programmer, and then there's The Art of Computer Programming, which is basically a collection of books designed to make you question every life decision that brought you there. If coding is just typing instruction into a computer, why does it require years of practice to become genuinely good at it? And why do some programmers become legendary? Think about people like John Carmack and Fabrice Ballard. Were they simply lucky enough to be typing code at the right time? Of course not, because writing software is a craft. It requires understanding abstractions, algorithms, architecture, performance, memory, concurrency, networking, security, debugging, and perhaps most importantly, understanding what happens when your beautifully designed system meets reality. Now AI has changed something important. Large language models can generate code incredibly quickly. You can describe a feature and suddenly you have hundreds of lines of implementation. That's genuinely impressive. But here's where the argument goes wrong. People see an AI generate 500 lines of code in 10 seconds and conclude, see, coding was never difficult. No. What you have actually demonstrated is that some form of code generation can be automated. Those are not the same thing. Generating code is not the same as engineering software because someone still has to decide, does this code actually work? Is it secure? Will it scale? What happens when the database goes down? What happens when two requests arrive at exactly the same time? What happens when the requirements change 6 months from now? Can another developer understand it? Can we test it? Can we maintain it? And what happens when the AI confidently gives you completely wrong code? That's the part that does not disappear simply because the code appeared instantly. Now there's another popular argument. People say, fine, coding might require skill, but that's not the hard part. The hard part is knowing what to build. And yes, that's absolutely important. Understanding customers matters, understanding business requirements matter, understanding user experience matters. Knowing what problem you're actually solving matters. But let's take this argument to its logical conclusion. If figuring out what to build is the hardest part, why are not product managers universally considered the most valuable people in software companies? Why are not market researchers the rock stars? Why don't customer success teams get the giant engineering salaries? And if salespeople discover what customers want, why do developers get annoyed when sales promises a customer some ridiculous new feature? After all, they found demand. And if implementation really is easy, why don't companies simply build 10 different versions of every idea and see which one works? Because the reality is much more complicated. Here's another problem. People love saying most software development is not coding. It's talking to stakeholders, understanding customers, and figuring out priorities. Maybe, but ask an actual group of programmers how many of them want to spend their entire day talking to customers. You will probably discover something interesting. A lot of programmers don't. And that's not necessarily a problem because software development attracts different kinds of people. Some developers love architecture, some love algorithms, some love debugging obscure memory problems, some love talking to users, some love product strategy, some just want someone to give them a clearly defined problem and let them build. And then there are developers who say, I don't write code, I solve customer problems. And 5 minutes later, they are arguing about monads, memory safety, try principles, and whether your abstraction violates some obscure software design principle. Meanwhile, their understanding of the customer is based entirely on a fictional user persona they invented 3 years ago. And then you have the other extreme, the developer who says software is mathematics, every program is basically a proof. And then someone asks, can you just upload this PHP file? And they react as if you have committed a crime against computer science. The point is not just one group is correct. The point is that software development is much bigger than one definition. Here's where I think we should land. We need both. We need people who understand users, people who understand business, people who can identify real problems, and we need people who can turn those problems into reliable software. Because knowing what to build does not magically tell you how to build it, and knowing how to build something does not automatically mean you should build it. The best engineers understand both sides. They understand the system and they understand why the system exists. That's the goal. Not code is everything, and not code is easy and irrelevant. And this is where AI makes the conversation even more interesting. One extreme says code is easy, AI will automate it all. The other say programming is pure human creativity. AI generated code can never replace real programmers. I think both are forms of denial, because we are clearly in the middle of a massive technological shift, and pretending nothing will change is just as dangerous as assuming everything will disappear. You don't need to blindly jump into an AI bandwagon. You don't need to become a manager of 500 AI agents, and you don't need to spend your career fighting AI because you believe the bubble will eventually disappear. Instead, understand what's actually changing. Here's the interesting part. Some things are changing incredibly fast, but some problems in software are basically immortal. Software will continue getting more complex. Software will always need maintenance. Technology will continue evolving. Abstraction will keep piling on top of abstractions. And users will always want more while wanting to pay less. They will struggle to explain what they actually need. And sometimes they won't even know what they want. There will always be a gap between the customer who pays for the software and the user who actually uses it. There will always be tension between business goals and customer needs. And yes, there will always be people selling the next revolutionary technology that supposedly changes everything. But here's the uncomfortable truth. Programmers have been disrupting their own profession forever. Nobody writes programs using punch cards anymore. Very few developers need to write assembly. COBOL is not exactly the language every new developer dreams of learning, and developers who spent years mastering memory bugs in C and C++ have seen entire classes of those problems become less common with newer languages and better tooling. Tools disappear, languages change, frameworks become obsolete, and developers adapt. That's always been the story. So AI is not the first disruption. It's simply a very significant one. So what should you actually do? First, accept that change is happening. Don't blindly believe the hype, but don't blindly reject it either. Be curious and be skeptical. Learn what actually works, experiment, and constantly ask what has genuinely changed. Not what tutor says changed, not what some AI influencer says changed. What actually changed. Because your role as a developer will change, maybe dramatically, and that means your responsibilities will change too. If you're a senior developer, don't just respond to AI by becoming even more obsessed with technical depth. Yes, keep improving your engineering skills, but also learn about the world around your code. Learn how users actually interact with software. Learn how customer interviews work. Understand product strategy. Understand the business your company is actually in. Because the more automation handles implementation, the more valuable it becomes to understand why that implementation exists in the first place. And if you're just starting out, don't make the mistake of thinking AI can write code, so I don't need to learn how computers work. That's exactly when you should go deeper. Learn pointers, learn recursion, learn memory, learn how CPUs actually execute instruction, understand networking, understand HTTP, learn algorithms and data structure, do lead code. Even if your day job is writing JavaScript, even if you're building WordPress plugins, even if AI writes half your code. Because when you understand why something works, you are much harder to fool when the AI gives you something that looks convincing but is completely wrong. So the next time someone tells you coding was never the hard part, don't respond by saying coding is art and AI can never replace me. That's not the answer either. Instead, recognize the bigger truth. Software development has always been about solving problems. Sometimes that means understanding customers. Sometimes it means designing architecture. Sometimes it means debugging a race condition at 2 a.m. Sometimes it means writing 500 lines of code, and sometimes it means deleting 500 lines of code. AI is changing how much of the implementation we need to do ourselves. That's real. But that does not mean engineering was easy. It means the definition of engineering is changing. And programmers have survived changes like this before. The developers who thrive won't be the ones who blindly worship AI, and they won't be the ones who desperately pretend it does not matter. They will be the ones who understand both sides, how to build the software and why it should exist. Because code was never easy, but it was never the entire job either. And now, more than ever, you need to understand both.